YOLO11 is the new state-of-the-art model introduced by Ultralytics. YOLO11 outperforms all the previous object detection models, including YOLO v10, YOLO v9, YOLO v8 in terms of speed and accuracy. YOLO11 can be used for a variety of computer vision tasks, including object detection, instant segmentation, object tracking, pose estimation. Some of the key improvements in YOLO11 include enhanced feature extraction, greater accuracy with fewer parameters, and faster processing speed. So YOLO11 is basically built on the advancements introduced in YOLO v9 and YOLO v10, incorporating improved architectural design, enhanced feature extraction techniques, and optimizing the training methods. YOLO11 medium model achieves a higher mean average precision on the benchmark Poco dataset while using 22% fewer parameters than YOLO v8 medium model. Along with this, YOLO11 brings a faster processing speed with inference time around 2% quicker than YOLO v10. So this makes this these feature enhancement techniques and make faster processing speed makes YOLO11 ideal for real-time applications. So this is a quick introduction about YOLO11. Let's dive into the code and see how we can do object detection, instant segmentation, image classification, object tracking, and pose estimation with YOLO11. So this is the Ultralytics repository, which contains all the code for YOLO11. And you can see YOLO11 is a cutting-edge state-of-the-art model that built upon the success of previous YOLO versions. Okay, and you can see over here, this blue line is of YOLO11, and you can see that YOLO11 outperforms all the previous object detection models, including YOLO v10, YOLO v9, YOLO v8, YOLO v7 in terms of mean average precision. And you can see the latency. Latency is basically the time that is basically the time to do object detection on an input image. Like the time taken to do object detection on an input image is basically the latency. Like how much time it takes to do object detection on an input image is the latency. So you can see that YOLO11 takes less time, and YOLO11 also outperforms in terms of mean average precision than all the other YOLO models. So YOLO11 outperforms all the other object detection models in terms of mean average precision, and it takes less time as compared to other YOLO models. Okay. And you can see that YOLO can be used directly in the command line interface with the YOLO command, and you can also use YOLO11 directly in the Python environment as well. So all these steps are provided. So YOLO11 comes with 25 open source models. Okay. So there are 5 models for the classification, 5 models for the detection, 5 models for the segmentation, and 5 models for the pose estimation. And you can use tracking feature with any of these models. So these are the models that the YOLO11 comes with: YOLO11 Nano, YOLO11 Small, YOLO11 medium, YOLO11 large, and YOLO11 extra large model. Okay, and you can see that YOLO11 Nano model has a mean average precision validation score of 39.5. But you can see that YOLO11 Nano is very much faster than other YOLO model, but YOLO11X, like extra large model, is better in terms of mean average precision score, like with 54.7, but it takes more time than other YOLO11 models. Okay, so there is a trade-off between speed and accuracy, which we can see over here. Okay. And similarly, you can see these are all the models for the segmentation, and these are all the models for the pose estimation, and these are all the models for the oriented bounding boxes. Okay. And here, these are all the models for the classification. Okay. And these are all the details. You can find all these details over here, and you can simply install the Ultralytics package, and then you can use YOLO11 simply. Okay. So this is all the repository. You can check out this repository as well, and you can see different examples over here as well. Okay. So here is our Google Colab notebook, and so over here, I have written all the code to do object detection, instant segmentation, image classification, pose estimation using Ultralytics YOLO11. Okay. So first of all, you can set the runtime as T for GPU because Google Colab offers free GPU and you can use this. Okay. So first of all, we will install the Ultralytics package over here. So this will take few seconds. So now you can see the Ultralytics package is installed. Now we will download some sample image and video from Drive. So I have added an image and a video on my Drive. So I'm directly downloading that image and video from Drive into this Google Colab notebook. And I will be doing object detection, image classification, instant segmentation, and pose estimation on this image and on this video. So let's see how we can do object detection in images using YOLO11. So first of all, we are using the YOLO11 pre-trained model, and we only want to do the prediction using YOLO11 pre-trained model, and we are using YOLO11 nano model. You can use other models as well, but YOLO11 nano is the most fastest model, but it is less accurate as compared to other YOLO11 models. Okay, and we are doing detection, okay, object detection, and we are doing prediction using YOLO11 nano model, and we are doing prediction on this sample image. Okay. So let's see. So now you can see YOLO11 is very much fast, and like it takes few seconds, like 10 to 15 seconds over here. And now you can see over here, we have our runs folder, and inside this we have prediction, detection, prediction, and here is our output image. So you can just copy the path from here, and you can just add this path over here, and you can see. Okay, so now you can see the output. We are able to detect a person, bus, traffic light. We are able to detect both the traffic lights over here. We are able to detect the handbag over here. So the results look very good from now. Okay. So like on using YOLO command over here, we are able to do object detection on an input image. Okay. Let's see how we can do object detection in videos using YOLO11. So you just need to add the path of your video file in the source, as all the other things will remain the same. Okay. So let's run this up. So our complete video is being divided into 458 frames, like you can see over here, and we are doing object detection on each of the frame one by one. Okay. So this will take few seconds. Like this is very quick. Like we are using GPU, so you can see that processing is very fast, and you can see it's done. And we'll use this code to display the output video in this Google Colab notebook over here. So, and this will take few seconds, and we have the output video over here. So we can also download the output video from here, but the size is very large. And here we have the complex output video being displayed over here. So we can download this. So let's wait for a few seconds before we. After this, we will see how we can do object segmentation or in images, or instant segmentation in images using YOLO11. And then we will see how we can do instant segmentation in videos using YOLO11 as well. So let's wait for this to finish up. And you can see that compressed file is being created. Now you can see over here, the size of this output video was 94.81 MB. And now the compressed video size is around 10.34 MB. Now you can see we have compressed video file over here. Okay, and you can see here is our output video. And let me download this video and show you. Okay. So now you can see over here, we are able to do object detection on the subject, like we are able to detect a traffic light, person, bicycle. So the results look quite good. Like you can see over here, we are able to detect the back, bicycle, person, traffic lights, road signs as well. So the results are very promising. Okay. Let's move ahead and see how we can do instance segmentation in images using YOLO11. So we are using YOLO11 nano dash segmentation model. If you see over here, we have the segmentation models available over here. Like you can see over here, we have the pose models. So you can use any of these models. Okay. So so now you can see over here, we are able to do instance segmentation on this input image. And you can see over here, we have our output saved in the predict folder. So if we just refresh this up, so you can see segment and the predict folder, we have our output image. So you can simply copy path from here and add this path over here. Okay, and let's run this. So now you can see over here, we are able to do instance segmentation on the bus, traffic light, handbag, person, backpack. Okay, so you can see the results look very promising. Okay, let's see how we can do object segmentation in videos using YOLO11. Okay, so let's run this up now. So you just need to add a video path over here and nothing else. So now you can see over here, the processing is very quick. Okay. So our output is saved to run segment predict 2. So if you just refresh this up, and here you can find the output video, and you can simply run these two cells from here, and you can see. So if I just run this again, this will take a few seconds before I have my output video being displayed over here. So let's wait for a few seconds. After this, we will see how we can do pose estimation in images using YOLO11. Okay? And we will also see how we can do pose estimation in videos using YOLO11. And then we will see how we can do image classification over here. And we will take an image of a sports car over there. Okay. So this will take few seconds before we have our output video over here. So let's wait for a few seconds. So you can see here we have our output video. Let me download this video and show you on a full screen how our output looks like. Okay, so let me just navigate. So you can see over here, we are able to do instance segmentation. Like you can see over here, we are able to type bicycle, person, traffic light, road signs, and the results look very promising. Like you can see over here, we are able to detect bicycle, person, traffic lights, and the results are very, very promising. Like these results are very impressive. Okay. Let's go back over here and let me just save this up now. Okay. So next, we will see how we can do pose estimation in images using YOLO11 over here. Okay. So we will just select the toss is equal to pose, mod is equal to predict, and we are using YOLO11 and dash pose model. And you can see over here, we have these pose models in the Ultralytics YOLO repository. You can just use any of these models. Okay. And so for object detection, we use the toss is equal to detect. For instance segmentation, we use toss is equal to segment. And for pose estimation, we use the toss is equal to pose over here. And we are using basically pre-trained model. We are not fine-tuning the model. So we are using the pre-trained model over here. And we are just setting the mod is equal to prediction. If you are doing the training or fine-tuning the YOLO11 model, you can see set mod is equal to train. But we are currently doing predictions. So we have set mode is equal to prediction, and here we have passed our input image. Okay. So you can see over here we have the post folder, and the predict we have the output image, and you can just simply copy path and just add this path over here. And here you can see we are able to do the pose estimation on the person over here, and the results look quite promising, like results are good. Okay. And let's see how we can do pose estimation in videos using YOLO11. So you just need to add the video path over here. And we are using YOLO11 post model. Mod is equal to predict and toss is equal to pose estimation. Let's run this up now. So this will take few seconds. Like you can see, we are able to make the person over here. So YOLO11 pre-trained pose estimation model can only do pose estimation of person. To do pose estimation of an animal or a class, you need to fine-tune the YOLO11 pose estimation model. But the pre-trained YOLO11 pose estimation model or other pose estimation models, YOLO pose estimation models, including YOLO8, YOLO V8 can do pose estimation of only person. To do any other animal or to do a pose estimation of any object, you need to fine-tune the pose estimation model of YOLO. Okay, so it's done now, and let's display this output video over here. Okay, so after this, we are only left with one task, which is image classification. Yeah. Okay. And we will do the classification of this sports car. Okay, and let's see how does it work. But let's display this output video first over here. And then we'll go ahead towards the image classification task as well. So this will take a few more seconds before we have everything ready over here. So here you can see we are our output video. You can just run this output video over here, but let me download this video and show you a big screen over here. So it's downloading, and let me open it over here, and let me navigate my screen towards it. So you can see over here, we are able to do pose estimation of person over here, and the results you can see are very promising. You can see we are also doing the detection over here as well, and we are also doing the pose estimation. So we are doing two things, object detection and pose estimation, and the results look very, very promising. Okay, so let's go ahead and go to our last task, which is image classification. Okay, so let's just save this up now. So now for image classification, we will download a car image, a sports car image from the drive directly into this Google Colab notebook over here. And we will set the toss is equal to classify, mode is equal to predict, and we are using a YOLO11 extra large model, and we are doing classification, image classification over here. And let's run this up now. And you can see the size of the YOLO11 extra large model is quite large, like it's 56.9 MB. The YOLO11 nano model is around 5.6 MB. Okay, so we have our output image saved into the folder for run, classify, predict. Okay, over here. So let me just display the output image over here. Okay, so if I just open this image into the new tab over here, we can just save. So if I just open this output image into a bigger window, so now you can see over here, we are able to, like for the sports car, the model is 66% confident that this is a sports car. And this for the car wheel, the model is 11% confident. For the cab, the model is 10% confidence. For the wagon, the model is 0.05% confident. for the racer, the model is 0.03% confident. But as we can see over here, this is a sports car and the model is 66% confident that this is a sports car. So you can see that how accurately we can do image classification. Like you can see over here, our model is able to classify correctly that this is a sports car. And you can see over here 0.66, basically this is 66%. Our model is confident that this is a sports car. So in this tutorial, I have presented you an introduction to YOLO11. We have seen that how we can do object detection, instant segmentation, image classification, and pose estimation using YOLO11. I hope you have learned something in this tutorial. Some exciting tutorials are coming ahead. Do subscribe my channel. Thank you for watching. Bye-bye.